Hello, my name is Duff, and today we'll be going over the KTANE module.
All available experts, please report to room A9.
Everything just went off. We'll be going over reverse Polish notation. Reverse Polish notation is a mathematical concept calculators used back in, I believe, the 70s or 80s. I'm probably wrong about that. But the point of reverse Polish notation is that calculators at the time did not have parentheses, and so they could not just handle the order of operations as a normal calculator would with parentheses. So this is the reverse Polish notation is the solution to not having parentheses on calculator, and it basically does its own method of calculating what order you want to do an equation in. But enough babbling about trivia, let's actually do the module. This module does require edge work, although you might not need all of it. It's, as you can see on the module, there are letters, and, well, there's one letter right now. And as you progress through stages, there are 3 of them, as you progress through stages, the equations get more complex, and the answers, or rather the equations, will probably contain more letters. So, our equation is d3 divided 3 minus, so let's just have this written down over here. I'm going to be using the textbook calculator instead of Notepad++ because, well, it just looks better for recording. So, d3 divided 3 minus. Now, let's go over how to actually read reverse Polish notation.
All personnel, please return to your stations.
How to actually parse the information given here. So, the way the manual explains it is that it has stacks, and these stacks, it gets very confusing to read. The way I prefer to explain it over the manual is you have 2 different queues. You have the number queue and the operator queue. So what you want to do is you want to go in from left to right to see what letters, or rather numbers, you have. So we scan this one, we have D, then we have 3, but we've encountered an operator. Once we've encountered an operator, we take the right 2 of our current number queue, and then we apply the leftmost operator to that queue. So right here, because our current queue is D and 3, and the leftmost operator at this point in time is divided, we would do D divided by 3. And while I'm explaining this, I should actually get the actual numbers or representations of letters for the module. So D is the sum of non-encoded numbers in the current stage plus 10. So the total is 6, and 6 plus 10 is 16. So our current total, or D, is 16 for this stage. Now, this is a module that rounds. I believe it rounds. So let me just quickly check. Decimal. Yep. Okay. So, whenever you have to do division, you'll have to round your answer to the thousandth place. So basically, 16 divided by 3 is 5.333. So our current stack right now is 5.333 at 3 minus. And the reason why 3 minus is here is because we didn't use that when calculating our stack. We only had 16.3 divided in the stack. Once you use those 3, they're gone from the initial equation, or from your new equation. So now we just have 3.333, 3 minus. And doing what we did before, going from left to right, we have 5.333 in the queue, then 3, and then we hit an operator of minus. So we have 5.333 minus 3, which gives you 2.333. So all 3's. So then we just input that into the module. Okay, 52F minus times C divided. I just write this down in textual calculator real quick before I switch over. Times C divided. Alright. So this is what I said when the equations get more complex. At least I believe I said that. No, that was my last recording attempt. This module is 3 stages, and as we progress through the stages, the equations get more complex, using more operators and more variables, or rather constants, or either, doesn't matter. And the variables, the letters, they can change per stage. They don't always have to. There's a set few that don't. However, this one does, or I believe F and C do. Well, F isn't. C also isn't. Never mind. I'm just a lying man. Okay, so let's convert these real quick. So F is the nth term of the triangle number sequence, where n is equal to the number of port plates plus PS2 and RJ ports mod 9. So first let me get the sum of these real quick. Port plates plus PS2 and RJs. That would be 1, 2, 3. We have 3 port plates and no RJs, or nor PS2s. So n equals 3. And let's see. And triangle numbers here. Okay. Here it explains it that the third triangle number is 6, and luckily for us, that is what we have. So, but to actually calculate the triangle numbers, you'd have, as it states, you just take the sum of all integers less than it. So if we have n equals 3, we would do 3 plus 2 plus 1, which equals 6, and that's what f happens to equal. If we were to have, let's say, I don't know, 8, we do 8 plus 7 plus 6 plus 5 plus 4 plus 3 plus 2 plus 1, which would be 36. Now, if you aren't a huge fan of calculating this, you could always just look it up. The triangle numbers is just an actual mathematical concept. So like triangle numbers. See? Now, do note that for this, the first triangle number is 1, while some other sites may consider 0 as the first one. But that's neither here nor there. Let's continue on with the module. C is the number of battery holders plus 2 divided by the last digit of the serial number. So, let's see. Looking at the bottom, we have no battery holders, and the last, so that's going to be 2 so far, and then we're going to divide that by 6. So let's flip over real quick. As it states somewhere, oh yes, I have decimal highlighted, or control left. Let's see. Oh, no, never mind. Okay, yeah. Whenever you have a decimal, you do the same thing as you would an answer, and where you would just round it to the thousandth spot. Never mind, I am lying. It says drop any remainders. Ignore everything I'm saying right now. So 2 divided by 6 is 0. However, if the letter returns a 0, we change it to a 1. So C is not actually equal to 0, it's equal to 1. So we want to change this. Okay, and then we go back to calculate. Right now so going from left to right, we have 5 in the queue, then we add 2 to the queue, and then we add 6 to the queue. And then we find a minus. Now this This minus only applies to the rightmost of our cube, which is the 2 and the 6. We don't include the 5 because you can't use one subtraction operator to 3 numbers. So this negative goes between these two numbers, so it's going to be 2 minus 6. You don't do any flopping around or flipping around. So 2 minus 6, that becomes negative 4. And then we restart our cube. So we have 5, then negative 4, and then we have a multiply sign, or multiplication symbol. 5 times negative 4 is going to be negative 20, so our current answer is negative 20. And then we continue on. Negative 20, then 1, then divided. Negative 20 divided by 1 is, well, negative 20. Any number divided by 1 is is the original number. So, we would enter in negative 20 onto the module. However, whenever you get a negative number, you're just going to drop the negative sign. So in this case, we're going to have the answer of 20. And this is our final equation, which, no letters, that's a bit weird. But let me just type this in real quick. We have 9, 7 minus 2, 6 divided 2 times and minus. So, let's go back to tactile calculator real quick. If you don't like the Q thing either, the Q explanation either, there is a third way to explain it, which is the simplest way to explain it, or to rather just do it. All you have to do is take the rightmost number that hasn't, the rightmost numbers of the leftmost operator, and then you apply those. So this is the leftmost operator. These two are the rightmost numbers. You just apply you just combine all three of these. So this becomes 2. This is the leftmost operator. These are the rightmost numbers. 2 divided by 6 is some decimal, 0.3333. These are the rightmost numbers. This is the leftmost operator, so this becomes 666. Oh wait, I'm sorry. I did something sort of wrong here. So, I went ahead and jumped the gun and decided that 2 divided by 6 is 0.333 and just truncated it right there. Only when you complete the equation should you round. You don't round early because, well, we have 0.333 and that's just going to change. However, if we truncate it there, right, multiplying by 2 gives us 0.666. However, if we don't truncate it, and then we multiply by 2, we're going to get 0.667. So that's why you should round at the very end. So let me just have parentheses here, which is not the point of reverse Polish notation, but yeah, I don't care. So now we have, so 2 times 2 over 6, that's going to be 4 over 6, which just translates to 2 over 3, which is 0.667. And then all we do is 2 minus 0.667, which is going to be 1.333. And let me just verify the thing, the fact that if you truncate it early, so our answer would be 1.334, when the true answer is 1.333. So, oops, that's not the switch screen button, this is. So if we were to do 1.333, no, that's the true answer, 1.334.
Please, Stanley, think about what you're doing.
That's a strike. But if we were to do 1.333,
this was exactly the way,
then it solves.
right now, that things were meant to happen.
Let's go ahead and go over another example, and hopefully we run it into an edge case that I can explain. If we don't, then whatever, I'll explain at the end.
All available experts, please report to room A9.
Okay. Ooh, this is a nice one. Stage 1, all the operators are on the right. Okay. So our current equation is 8d 0 minus plus. Alright. So, d, let's go ahead and translate d. Sum of the non-code numbers plus 10. Well, that's just going to be 18. Alright. Now, we take the leftmost operator and look at the rightmost two numbers of the leftmost operator. So we're going to do 18 minus 0, which of course just leaves us with 18. Then we take the leftmost operator, in this case the only operator, and the only numbers left, and then we just do the operator on them, which is 8 plus 18, which gives us 26. So we just input 26, and we move on with our day. Now we have 9d divided 0c times divided. So, as I stated before, well, just like in the last stage, d is the sum of the non-encoded numbers, so 9 plus 0 is just going to be 9, and then add 10, so that's going to be 19. Then we take a look at C, which is the number of battery holders plus 2 divided by the last digit serial number, and then we drop any remainders. So we have 2 battery holders, so our current number is 4, and the last digit of serial number is 1, so 4 divided by 1 is just 4. Alright, and that's all the numbers we have to take care of. Okay, so first one up, our rightmost numbers of the leftmost
Emergency
operator.
cleared. All personnel, please return to your stations.
Ash, please, I'm giving a tutorial. So, yeah, the leftmost operator is the division sign, and the rightmost are 9 and 19. So we do 9 divided by 19, which is this lovely number. I'm just going to have this in parentheses so we don't have to deal with this later. And then we move on. Ooh, we actually did run into the edge case, good. So the leftmost operator is the multiplication symbol, and the rightmost numbers are 0 and 4. So 0 times 4, that's just going to lead to 0. Now then, we have to divide by 0. What do we do? Well, the manual states that if we have to divide by 0, then we let the answer be 0. So, this is just, when it says the answer will be 0, that doesn't mean the final answer will be 0. If we have a complicated process of like 9 divided by 0 plus 7 blah 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 blah, right? Our answer to all of this isn't just going to be 0, because we have to divide by 0 here. The answer to this one is just going to be 1. So the answer to this equation right here is going to be 1. Whenever you have to divide by 0, let that lead to 1. Don't divide by 0 and have a panic attack. So, let's just input the 1 and continue on.
No, really? Perhaps not.
That's actually confusing. Okay. Well, we all make mistakes. Let's see what went wrong here. Alright. Oh, my bad. Sorry. I was thinking about this. If we have to divide by 0, then our answer is 1, not 0. My apologies. I should have actually read the manual instead of trying to remember it. But what I said is the same. Sorry, so right here it says if you have to divide by 0, let the answer be 0. I was thinking about this. So let that be a lesson to you. Don't memorize this manual. So, but okay, let's just input the number of 0. There we go. And let me just get rid of that. Okay. So, this one's also an interesting equation. So we have 9fa4 minus f times minus. So let's just go through all these operators. Let's see, the product of the number of batteries and the number of modules on the bomb, excluding needies. We have one module on the bomb, and we have 2 batteries, so A is just going to equal 2. F, on the other hand, is the triangle number question again, or triangle number again. So, let's see, we want to add the port plates, PS2, and RJs. We have 1 port plate, no, we have 3 port plates, 1 PS2, and 0 RJs. So we want to calculate the 4th triangle number. So if the 3rd one is 6, then the 4th one is going to be 10. So we're just going to replace these F's with 10s. And then we carry on. So the leftmost operator is this minus, and the rightmost numbers are this 2 and the 4. So 2 minus 4 is going to be negative 2. And then we can continue on. Negative 2 and 10, that's going to become negative 20, get rid of this multiplication sign. 10 and negative 20, that's just going to become 200, get rid of that. And 9 minus negative 200. Remember guys, if you subtract the negative, it becomes positive. So that's really 9 plus 200, which gives us 209 for our final answer. So we just input this into the module. That's a clear run.
This was exactly the way,
and it solves.
Right now, that things were meant
Before I end off this tutorial, I'll quickly go over some of the other variables, or I'll just speed run through all of them. So we went over A, B, the square of the difference between number of ports and number of indicators. So that's basically just ports minus indicators, and then you square it. This should never be a negative number because you're squaring it. E is serial ports plus parallel ports. Stages 1 or 3 multiplied by the third character serial number. Now the third character serial number is always going to be a letter, or rather a number. So you should be fine. If you have serial number modifier, I have no idea what's going to happen if it tries to multiply by a letter. But yeah, that's if it's stage 1 or 3. If it's stage 2, then you're just going to add the third character to serial number. Ooh. And this one is actually a special one. The Lunar Edition of the number of solvable modules on the bomb and the whole number of minutes, rounding down. So let me just go over Lunar Edition real quick. So in Standard Edition, we have, let's just do something like 209 plus, I don't know, what, actually let's do 219 and 187. Right, so if we were to add these up, this 9 and 7, that becomes 6, or something 6. Right, we carry the 1. 1 plus 1 plus 8, that becomes 0. Carry the 1. 1 plus 1 plus 2, that becomes 4. So the answer in normal addition would be 4 or 6. However, Lunar Addition doesn't work like that. For Lunar Addition, you take a look at each digit, and then the answer for that slot is just going to be whichever digit is higher. So we compare the 9 and the 7, and we see 9 is higher, so the 1 spot is just 9. There is no carrying over whatsoever, so we just move on to the next slot. We have 1 and 8. 8 is higher, so the answer is just 8. 2 and 1, 2 is higher, so the answer is 2. So it's just 289. And that's what you do for letter G. But anyways, that's all I have for this tutorial. If you have any questions, leave them in the comments below, and get a job.